This video is on section 4.2 notes, measures of central tendency. So, measure of central tendency is a single number that summarizes an entire data set, specifically the middle value of that set. We often call this the average, but technically the average is usually specifically referring to the mean. So when we talk about mean, median, and mode, then we're referring to measures of central tendency. The mean is colloquially known as average. It's calculated by adding up all the values in a set and dividing by the total number of values in that set. The median is the middle value when all of the values are arranged in order from smallest to largest. If you have an even number of values, then you would just take the two middle values, add them together, and divide by 2. The mode is the value that occurs the most often in the set. And we have sets of data that could be unimodal, bimodal, trimodal, et cetera, and so on. So a unimodal data set has exactly one mode or one number that is repeated most often. A bimodal data set has two distinct numbers that are repeated most often. A trimodal data set has 3 distinct modes that are repeated most often. And it's not saying, oh, one number is repeated 5 times and another number is repeated 7 times. It's saying that whatever numbers are repeated the most often, they are repeated an equal number of times. And so you can't say which one is repeated the most because they're the same. All right, so here there's a little note. It says if the mean is not exact, round it to 1 decimal digit more than the least precise data value in the set. So in this data set we're about to work with, everything is rounded to the nearest 10th, 1 decimal place. So when we find the mean, we're going to round it to 2 decimal places. That's what that means. All right, this example says an airplane mechanic was asked to prepare an estimate of the cost for an annual inspection of a small Bonanza aircraft. The mechanic's records showed that 8 prior inspections on the same type of plane had required 9.6, 10.8, 10, 8.5, 11, 10.8, 9.2, and 11.5 hours. To help prepare his estimate, the mechanic first found the mean inspection time. How many hours should he use to calculate his cost estimate? So we're going to go ahead and find the mean just by finding the sum of all these data values, and then we'll divide by the number of data values that we had. So 9.6, 10.8, 8.5, oh, I skipped 10. 10, 8.5, 11, 10.8, 9.2, 11.5. So the sum that I get when I add all of those up is 81.4. And then we had 1, 2, 3, 4, 5, 6, 7, 8 data values. So I'll divide by 8. And I'm going to round this to 2 decimal places, so 10.18. A machine shop produces 7 copies of a steel disc. The thickness of the discs, as measured by a vernier caliper, are in inches: 1.738, 1.741, 1.738, 1.740, 1.739, 1.737, and 1.740. What is the median thickness and what is the mode? So we have to put these in order from smallest to smallest to biggest to find the median, and then it's helpful to do that to find the mode as well. So the smallest thickness here is 1.737. 2 at 1.738. One at 739, 2 at 740, and then 1 at 741. Okay, 1, 2, 3, 4, 5, 6, 7. So there's 7. So that means that this one is the middle. So that's the median. These are in inches. And then there are two modes. This data set is bimodal. This thickness is used twice, and this thickness is used twice. And so neither one of those is better than the other. There just is two modes. A daily survey revealed the following prices for a gallon of regular unleaded gas at various stations in a certain metropolitan area. Find the mean, median, and mode of these prices. In the instructions, they also could have said, find the measures of central tendency. And if they'd said that, then we would have wanted all three. All right, so I'm going to go ahead and put these in order just because we're going to have to do that anyway. So it looks like the smallest amount that we have is 235. And then 239, 239, 239. And then 245 and 249. And then 255 and 259. And then this one down here was the biggest one, 265. Okay, so for the mean, I'm going to find the sum. 1, 2, 3. Okay, so the sum is, I got a different number than when I did it beforehand. Let me type those in again. Okay, I got 2469. There are 10 numbers. And so I get 2.469. And so my mean now here, even though all of these are rounded to 2 decimal places, and using the rule would mean that I would round it to 1 more decimal place, I'm going to leave it at 2 decimal places because the mean value is in terms of dollars and cents, and it only makes sense for me to have 2 decimal places for this. So I'm going to say 247. Okay, I went back and added it up again because this was different than what I got. You can see I've added it up multiple times. 2474 is what I got. So I'm going to fix this. And then when I divide by 10, I get 2.474. But I'm still going to round to 2 decimal places, so I get 247. Okay. The median is the middle number, so I have 10, so that means that I'm going to have 2 middle numbers. So 1, 2, 3, 4, 5, 6. There's my 2 middle numbers, so I'm going to add them together and divide by 2. 2.45 and 2.49 added together, divided by 2. It's 247. And then the answer, or the number that is repeated most often, is 239. It's repeated 3 times, and none of the other answers are repeated that much. So that's the mode. All right. Next, we're going to talk about frequency distributions. So a frequency distribution is where data values are placed into groups or categories with their corresponding frequency. So frequency is how often that data value or that group of data values is found within all the data. The classes are the groups or categories the data values are placed in. So here the classes 10 to 19, and we'll see some more classes when we fill this in. The frequency is the tally of the number of values within each class, and the class width is the difference between the lower limits of 2 consecutive classes. So the first class says 10 to 19 hours, and the second class says 20. So the class width is a width of 10 because the lower value for one class is 10 and the lower value for the next class is 20. So if we go by tens, the next lower value would be 30, and then 40, and then 50, and then 60, and then 70. And then the upper value for the classes would be 29, 39, 49, and you can see these are going up by tens as well. 59, 69, 79. Okay, so what we want to do next is we're going to look at these data values. They represent the number of hours during 1 week that a group of drafting students spent working on the conception, design, and modeling of a crankshaft. So we're going to tally them up and then we'll determine the frequency. So 16 and 19, 53, 59, 56, 33, 32, 13, 46, 61, 73, 26, 27, 25, 23, 32, 30, 63, 46, 45, 16, 42, 41, 45, 56, 15, 30, 39, 37, 24, 34, 17, 30, 39, 48, 21, 37, 24, 27, 31. Okay, so this is 6, 8, 12, 7, 4, 2, 1. Okay, so create a frequency distribution of the data. That's what we just did. Then find the mean number of hours worked on the crankshaft design. So to find the mean number of hours worked on the crankshaft design using a frequency table, we have to find the mean of the grouped data. So this follows 5 steps. The first step is to find the midpoint of each class. So we're going to extend this table. And we're going to find the midpoint of each class. So I'm going to add the lower value and the upper value of the class and divide by 2, and that'll help me find the midpoint. So 14.5. 24.5, and you'll notice that since the class widths were 10, the lower values are 10 apart, the upper values are 10 apart, the midpoints are going to be 10 apart as well. So this is 34.5, 44.5, 54.5, 64.5, 74.5. And it's pretty common for a midpoint to have a 0.5 in it, so don't be alarmed if you see that. Okay, next, multiply each frequency by its corresponding midpoint and list these products as the product F times M. So 6 times 14.5, 8 times 24.5, 12 times 34.5, 7 times 44.5, 4 times 54.5, 2 times 64.5, and then 1 times 74.5. Okay, step 3 is to find the sum of the frequencies and enter it at the bottom of the F column. So we're going to sum this up. So 40, this means that there were 40 pieces of data. Then find the sum of the products from step 2. So we're going to sum all of these. Okay, and then last we're going to divide the sum of the products, 1,430, by the number of data values. So it's just what the mean typically is. It's the sum of all the values divided by the number of values you have. So we're going to do the sum divided by the number of values. And so the mean for a grouped data set would be 35.75. And typically, if you were finding the mean of grouped data, you wouldn't be given the data. You would be given this table, and that's it. And they would ask you for the mean of this table, and then this is what you would do. In this problem, we could have taken this data set and just found the mean of it. But typically, you would find just this data set, you would have the frequency, and then you would have to find the mean based off of that alone.